Hello, everyone. Welcome back to the SciGeeks podcast. And as you can see today, we are in good company, and we are going to present a solution that can help you if you find yourself in a situation where you have a Kubernetes cluster where you run all your payload, normal payload with machine learning frameworks, but you have no GPUs available. And maybe you have a lot of GPUs ready to run heavy tasks on a remote cluster that you can access in a different way. So what you can do at that point? Well, one of the possible answer might be using Liqo. So we are here to present what Liqo is and how it works. So welcome, Francesco and Alessandro. I don't know who goes first. Well, let's introduce yourself and say
Yeah,
hi.
I can start. Hi Diego, hi everyone. I'm Alessandro. I'm one of the maintainer of Liqo. I started working on Liqo a lot of years ago during my studies in Politecnico di Torino, and now I'm continuing on on Liqo. Francesco.
I'm Francesco. I'm a cloud engineer too, working in ArubaKube, and I'm a maintainer of the project Liqo. Basically, I started working on Liqo at the university too during my thesis. I mainly focused on the network park, but we will have time to talk about this topic.
Yeah, sure. So I know you prepared some slides to introduce better all the key concepts here and there, but just let me check with people connected if they have want to say hi or have any introductory questions that want to do. Just briefly, while I'm remembering people that, of course, we are talking about virtual kubelets and virtual nodes in this episode, just like we started some time ago with Dario, and even before with some episode of interlink introductions. So yeah, this is kind of the fil rouge of the initial phase of the podcast. If you have any other use cases you want to report, feel free to reach out to me, and we will see how to put this in an episode. Okay, I see no comment in the chat. So what about starting presenting your slide? I don't know. Again, we're starting. Let me just, okay, maybe here is most visible. And
Okay.
yeah,
I
tell
think
me a bit more about,
I
yeah.
think we have our faces, but we already presented. We can
Yeah.
we can go on. So Francesco.
So let's start talking about Liqo. What is Liqo? So just a bit of history. Liqo was a research project born at the Polytechnic of Torino, and it was born in 2019. And after a long history of iterations and changes in the project, now we are reaching a maturity. And at the moment, the main contributor, this is important to say, is ArubaKube. Liqo is open source. I say that because everything you will see today, which is a demo, basically a demo that allow us to explore some technical details of Liqo, it's free, so you can find everything on our repository and you can use it for free. And basically, Liqo allows you to enable multi-cluster and multi-cloud topologies in Kubernetes. Just to understand what we mean with multi-cluster, let's imagine Kubernetes. We like it because it simplifies the management of machines, of what we call nodes, and allow us to create an higher level of abstraction upon our machines. So what we are trying to do with Liqo, it's something similar, creating what we call cloud continuum. And in practical, the idea is to have a central cluster and connect this cluster with other remote cluster, and then you can deploy your application on the central cluster, and the pods and the workloads will be free to spread on every cluster and communicate with each other. Just a few words about the fact that we are independent from providers, cloud providers. So Liqo can be used on every provider, AWS, GKE, AKS, but also in on-premises environments. So we can start with the demo. Alessandro, the stage is yours.
Okay, we can present.
Yeah, just
okay.
yeah, just a question. Sorry. So essentially, the idea is to get some abstraction from the perspective of how you manage Kubernetes resources, right? Do I understand? Do I read it correctly? So
No, not directly.
no, yeah, okay.
Yeah. The idea is to have one cluster where
Offloading
offloading
to
using
the other one.
we will see
Yeah,
how, but using Virtual Kubelet. Yeah.
yeah, right, correct.
Yeah.
Not a real abstraction, an offloading procedure,
Yeah.
offloading interface.
Okay.
Okay, kind of. Yeah. So okay, sorry. Go ahead.
Okay. I can start presenting a little bit the use case scenario that we want to present in our demo, where we have Mario, a machine learning engineer that wants to train its neural networks to classify fashion images. But its challenge is that he does not have direct access to GPUs in his dev cluster that the company provide him. So Mario is not a cloud engineer, so he's an AI engineer, machine learning engineer. So it uses Jupyter notebooks in order to create, to develop and test its algorithm, and it uses Kubeflow in order to provide this Jupyter notebook. Kubeflow completely hides the Kubernetes cluster, so Mario doesn't even know that it's running on top of Kubernetes. But under the hood, we have in our demo we have a first Kubernetes cluster. It is this orange box that we can call consumer cluster because it's the cluster that will acquire other resources from others. This cluster currently in our demo is built with K3s on Aruba Cloud VMs, but you can have it in any provider you want, or also on-prem. Kubeflow tries to schedule a new pod with a Jupyter.
Yeah, sorry
Okay.
to interrupt again. I want to stress this. So this is essentially something that you can find in ArubaKube as a service if you want, but it's independent from its Kubernetes native, right? It has
Yes,
nothing
it's
to do
a, it's
with.
a standard K3s cluster. This one you can use kubadm, you can use managed cluster from the provider you want to use. It's absolutely Liqo is an Helm chart that you install in your cluster as its own sets of CRDs and operators that run natively on Kubernetes.
Okay,
So
cool.
it's absolutely what you want. And the CNI you want. We are testing with the CNI with the main cloud providers. We are testing with Calico, with Cilium, etc. In order to have really you can have the infrastructure you prefer. So when this Jupyter notebook that we will create requiring GPUs will be a pending pod because we don't have GPU nodes in our cluster. In our setup, we also have a second cluster, this Violet cluster, that again for this demo we are using Aruba GPU server. But again, can be every cluster, every Kubernetes cluster you want. Again, here we have a K3s cluster running a single node cluster on this server for simplicity, but you can have really whatever you want. In this cluster, we have NVIDIA GPUs attached to the node, and we installed the GPU operator on this cluster. So what we will do in the demo with Liqo is with Virtual Kubelet is to create a virtual node on this on the consumer cluster in order to have new GPU available for this cluster and making this Jupyter notebook pod schedulable and running on this node. Liqo will create a network interconnection to the internet to the pod actually running in the remote cluster, and Mario will be able to use its Jupyter notebook in order to do its everyday job. Okay, so that one is mainly the setup for our demo.
Yeah, I have a question from IC's BoyX that is asking if, yeah, I suppose the answer is yes. If using taints annotation to select the correct node for a workload is what you meant.
Yes, we have a taint set to the virtual node, obviously, because we don't want that everything can be scheduled on that node. Then Liqo works on namespace basis, so we will see after in the demo more details. But we work by namespace, so you can offload what we call offload a namespace. Making the namespace eligible to be scheduled to a remote cluster. So when you set a namespace as offloaded, all the pods running by default, all the pods running in this namespace will be patched by a webhook in order to have a toleration for this node. Obviously, every node we create have a specific labels, so you can also use node selectors in order to specify a specific remote cluster or to specify only want local pods, only remote pods, etc. In this demo, we also enabled an additional feature of Liqo, that is the runtime class. So you can create pods with the Liqo runtime class, and automatically Kubernetes patches your pods in order to add the taint and add another node selector in order to run all the pods on the virtual node. It's specifically useful when you want to clearly understand which pods are local and which pods are remote, because you only need to patch the flooded ones. So the local ones, you don't need to touch them because they don't get the taint in order to be scheduled on this
Okay. Yeah. Cool. Go ahead. Thanks.
Okay. Then before the demo, I leave Francesco to a little deeper explanation on how Liqo works.
Yeah, so I'm going to talk about the Liqo modules. Liqo is made of three main modules, the networking, the authentication, and the offloading. So the first one, just create what we call network fabric, which is a network overlay that use the CNI and is CNI agnostic, as Alessandro said before, and allow you to get a pod-to-pod connectivity between every cluster in your topology. Then we have the authentication module that manages the life cycle of Kubernetes users. Basically, it is the management of the kubeconfig used by the Liqo components to talk with the remote clusters. And then we have the offloading module, which allow us to create the so-called virtual node powered by the Virtual Kubelet. And it also allows using the Virtual Kubelet to reflect some resources that are used usually for the Kubernetes applications, so like pod, services, endpoint slices, config maps, and allow to reflect these resources from the central cluster to the remote clusters. What is really important to say about the modules is that they are independent, so you can enable and disable all the modules. Of course, there are some features that we call cross modules, and that you can achieve only if you have 2 modules enabled at the same time. For example, we will see an example about how the network modules and the offloading modules are able to talk with each other. And what is also important is that every module has its own API. So what we mean with API, we didn't say before, Liqo is a set of controllers and Kubernetes operators. So to manage these our features, you need CRDs. And when we talk about APIs, we mean CRDs, because basically in Kubernetes are REST APIs. And another thing you can do with this division in modules, you can disable, for example, the networking module, and you are able to use other projects to make your pods to communicate with each other. This because we noticed during the time that when you create a cloud-native product, it's really important.
I don't know if it's only me or
yes,
we have.
me too. I missed the audio.
We cannot hear.
Sorry.
Okay.
I pressed the space bar. Sorry. Now I was saying that we learned with the time that it's really important to be compatible with other CNCF projects if you want to be successful. So we can go with the network part.
Yes, sorry.
Okay. So, okay, in this slide we see 2 clusters, okay, 2 vanilla clusters, and we start talking about what we call the external network. So basically, Alessandro, okay, thank you.
I missed it.
Okay, we create 2 pods, okay, with a tunneling technology implementation. In this case, we are using WireGuard because it is the default implementation for the gateway in Liqo. Then here in this picture, for the simplicity, we didn't create a difference between the gateway, between the 2 gateways, but one gateway acts as a client and the other as a server. In fact, we are going to talk about gateway client and gateway server. Of course, the pod running the gateway server must be exposed using a service or a service that can be a node or a load balancer. It depends on your infrastructure. So we can move on. Then we have the so-called internal network.
Can I ask you one thing? So what's the difference between server and the client, where you store the state or?
The server is the difference is that in the case of WireGuard, the server must be exposed and the client.
Okay, so
either
of the
you
either
have,
or two.
you have a load balancer. You have a
Okay,
load balancer exposed in the server.
Bars, node port, whatever you want.
So it's a WireGuard endpoint that you expose. Yeah, okay.
But then we will see that you can use other implementations. For example, you can use OpenVPN, etc., etc.
Okay.
Now we're talking about the internal network. Here we use Geneva. Geneva, for who doesn't know, is a tunneling protocol using UDP that doesn't encrypt the traffic, and that we will see why we decided to use Geneva. And we create tunnels from each node to the gateway to allow traffic from the pods to reach the gateway. This is necessary because we encountered some problems with the CNI because, in Kubernetes, the CNIs are responsible for everything that is related to routing and firewalling on the nodes. So if we try, for example, to add a routing rule that say, okay, all the traffic that must go from I see there is a question about nothing. Yeah, of course, you can. There is a configuration inside the gateway server, and you can specify that when you exchange the resources, the client have to use an external IP, which is the endpoint of your NAT.
The question is about the client behind NAT. So the client, yes, without configuration.
The client, sorry.
So the server, you can configure it to work behind the NAT. But the client, you don't need any configuration, so it works.
But also the server can be behind the NAT. Yeah.
Obviously, you need to expose the port. You have to have a proper word for.
So talking about the why we choose to create this tunnel, if you try to put a rule to route the traffic from the node to the other cluster, and you say, for example, a rule that say, okay, if you want to go to this cluster, you need to reach this pod using its own IP. The CNI say, no, that's something strange, and decided to block the traffic. In some cases, for example, with Calico is much more aggressive and decided to delete the rules on the node. So we have to do is to create this tunnel that basically trick the CNI, and so we are able to route all the traffic inside the tunnel. And so the CNI don't know where this tunnel is pointing, and the traffic is able to flow to the other cluster. And this tunnel is created from the node to the gateway pod, because in this case, in this way, we are using the CNI, okay, the CNI network to establish the tunnel connection. Another thing, if you need, for example, encryption, yeah.
This.
What?
Sorry, I think he has
Can you hear
me? If you need, for example, yeah.
Yes.
Yeah, sorry,
yes.
my
no,
connection drops for a second.
Okay.
The setup of these tunnels is all managed in a Kubernetes way, I suppose. So you have daemon sets or something that configure all the tunnels that you need. Okay.
We have a daemon set running on each node to set up the route, what we call routing configuration and firewall configuration, because we decided to manage all the routing rules and firewalling rules. The firewalling rules, we use NF tables because we want to try it instead of IP tables. And we manage all using controllers. So we have a set of controllers that apply these rules. On each
we have a set of controllers that are creating custom resources that are routing and firewalling custom resources, and then we have controllers that are applying them to the nodes.
Yeah. To the nodes and to the gateway, because
to the gateway, yes.
Some networking rules that has to be set up inside the gateway. Then another detail about our network, if you need to use encryption, for example, it's enough to enable encryption inside the CNI, because our tunneled traffic go inside the CNI, and we don't have a limitation about pod siders. So, for example, the two cluster can have the same pod sider. We have a mechanism we call remapping. So every cluster is able to remap the other cluster siders, deciding a random sider, okay? And it is all managed inside the gateway. So inside the gateway, basically, we have some firewalling rules, source NATing rules, destination NATing rules that are able to modify the packets that pass inside the gateway. Another detail about the network, of course, it can work with more than two clusters. So you can have a central cluster and more leaf clusters. When you have to communicate between the central and a leaf, the logic is that
Francesco,
you press the space bar again.
The logic is the one described in this image. When you have to communicate two pods in two different leaves, the logic is a bit more complicated, but basically it follows this idea. If you are interested, we can talk about it later. And last thing, we thought about pod and pod IPs, but we know that in the real world, people never use services, never use pod IPs, but we use services. So this is an example of how the offloading module can communicate and collaborate with the networking module, because we can use the virtual kubelet to replicate and spread on every cluster the used endpoint slices and the services. So basically you can find, thanks to the virtual kubelet, on every cluster a service that can be used to reach all the replicas of the pods in every cluster. There is a question: does Liqo works also with Kubelet to replace kubeproxy? Yes, but we have some limitation at the moment. We know how to resolve, but it's something we plan for the future. Basically, if you replace kubeproxy, we have some problems with node ports, because there are some rules that are ignored because it is using a BPF.
So node port, if you have a remote backend for the node port. So if if you have an offloaded pod that is a backend for a node port service, you will have a problem with the Cilium kubeproxy.
But for example, if you just have traffic inside the cluster, it works without problem. And that's all for this part. Okay. Just a few words about the CRDs used to configure our network. We have the configuration resource, which contains the information about podsiders and other network configuration that is exchanged between the two clusters. Then we have the gateway client and gateway server that allow you to create the deployment and the services used by the gateways. And it's really important to understand that when you create the gateway, you have to specify a gateway template. And that's where we introduce the possibility to use other implementation. The gateway client template and the gateway client server template are basically two manifests with the definition of the deployment and the services used inside of it. So, for example, if you want to use another implementation, you can create a new template, change the image used by the gateway, implement another solution, for example, using OpenVPN, and then you can create a gateway that target the new template. And then we have the connection resource that allow us to understand the status of the connection in the tunnel. So basically you see, okay, the tunnel is connected, there is an error with the connection, and then we have also some information about the latency of the networking.
Yeah, I think we can see that in action if you want.
Yeah, that would be cool.
Let me present the environment. So we basically have the two clusters we presented you before. So we have on the left we have the orange one, so the consumer one, while on the right we have the violet one, the provider cluster. So we are seeing the nodes in the cluster and the pods that are the Liqo tenant namespaces on both clusters. Liqo tenant namespace is a namespace where Liqo will use to create the pods responsible for the Liqo control plane. So you will have the gateways, you will have, after we will see also the virtual kubelet in this namespace. So what we need to do in order to set up everything we talk about until now is to use LiqoCTL, our CLI tool, and to ask LiqoCTL to init the network. LiqoCTL uses the kubeconfig of a cluster, so it's the cluster we are targeting now. So the consumer one, we are passing to LiqoCTL the kubeconfig to the other cluster where you need to exchange the information. The network init command, we can run it. It sets up the configuration. So now the two clusters are are aware of the podsider of the other. Once the network is set up, we can simply run Liqo network connect. Again, here we pass the remote kube config with remote provider kube config. So the server that will be the cluster that will be the server for our network connection. Obviously, we are using now the provider as a server because it's the default that we are using, but we can also set the consumer as a service for the VPN and switch its roles.
Okay,
We are
one
using
question.
several.
Sorry.
Okay,
Yeah,
sorry.
sorry. There is any way, yeah, probably also by yourself you can do something already, but to monitor the traffic on this network fabric.
Yes.
It's something
No, we have
Oh, sorry.
the metrics between the two clusters.
Yeah.
So we have metrics
Okay.
about the connection between the two clusters, not in the internal network.
But it's something planned. Yeah, it's
Yeah.
something we want to
Okay.
do. Yeah.
Yeah, basically you have the
Yeah.
bandwidth of between the two clusters and the latency that we have between I think that we didn't install the metrics exporter on this installation, so I cannot show you on
No,
Prometheus, but
no.
No
yes,
problem.
we have it.
Yeah.
So running the LicoCTL network connect, we are using node port service type because we didn't install the load balancer in the provider cluster. But obviously, in production cluster, we can use load balancer. So we can run this command. LicoCTL will create a new gateway server in this cluster, so we can see that a new pod is up and running on this cluster, and a new gateway client running on this cluster. You can check only for these resources. For example, gateway clients that is running and gateway server. Okay, sorry, I missed space. That is running, and we can see that the client is targeting the same VPN ports made available for the server. We can see also for the connection resource, that is the resource, as Francesco said, that is used to the other modules in order to understand if the networking module is ready and the connection is established. We can see the connection. We have both in the client and in the server cluster, and are both in the status connector. Obviously, we have different types. Obviously, we can go very deep on this, but I think that we can stop here. If we have specific question, we can go deeper for a specific things. I think I don't know, Francesco, if you want to add something
No.
more, but
No.
So for now, for the networking model, I think we are almost okay. We set up everything we explained before. So we have the tunnel between the cluster, and we have the internal tunnels with Geneva already set up with these simple commands. Now I can move on and explain also high level how the other modules works, and then we see also this module in action. So basically, what we do is to in the authentication in the flooding modules is to make the consumer cluster able to schedule to run pods, services, etc. In the provider one, and to give to the virtual kubelet the permission that it requires to schedule them. So we have two different kind of users and permissions in Liqo. We have the control plane permissions that are the permission required to operate in the tenant namespaces we see before. So they are once per couple of cluster. Then we have the resource slice that is the resource that the consumer cluster need to create in order to consume resources from the other cluster. So here we can create ask the resources that we want to use, and the provider cluster will provide us the resources what we requested, or defaulting them with different values. Then we have the quota, that is a resource limit, cross-current namespace resource limits related to the resource slice, and we will create a resource, our custom resource, that is the virtual node, that basically is responsible for the life cycle of the pod that is running the virtual kubelet, for the node that is exposed to the cluster, etc.
Can I ask one question?
Sure.
So tell me if I'm reading this correctly or not. So to me, this looks like very similar at the logical level, not at the implementation level, to the experience you have when you, for instance, create. I don't know if you had any experience with V cluster, with Stockcaster.
Yes.
Yeah, so this capability to explain what you want to share, what you want to consume from the parent one, or want to share from the parent to the child, is this something close to this approach, or does it
It can be
make
kind
any
of.
sense?
Obviously, it's different because the cluster
Yeah,
works inside a single namespace.
yeah,
If you
technology
want to
aside,
have
let's say. Yeah,
is a completely different in that perspective. But yes, it's something similar. So you can bind a quota to a specific Kubernetes user that the remote virtual kubelet will use in order to create resources. This quota will also bind to all the namespaces that this cluster is creating. Yes, kind of. Also, the reflection that the virtual kubelet does from one cluster to the other, it can be something similar of what
yeah,
the
exactly.
cluster does between the infrastructure cluster and
Yeah,
I don't remember how they call them, but the user cluster
yeah,
where you're running. I think it's very similar in the. Obviously, we do something different because the
it's not
scenario is
it's not
different.
the same cluster. Yes.
Exactly, but it's kind of very similar to this. Okay, I can show you. So we are here again. We already set up the interconnection between these two clusters. So let me clean a little bit the space. So now we are trying to LiqoCTL authenticate to the remote cluster. So the remote cluster is the provider one. So we are authenticating the consumer one in order to have permissions in order to operate to the provider cluster. So it is creating the tenant, is signing certificates. So we have private keys that doesn't leave the consumer cluster, and we are creating a X509 certificate in order to operate to the API server of the provider cluster. Here we have a tenant that is a cluster scope, the resources that contains the information and the settings about the specific consumer cluster. Here we have identity. We have an identity created. The identity basically contains the kubeconfig that we use to operate the remote cluster. Now, from the control plane perspective, we are ready. So the consumer cluster is able to ask a resource to the provider one. And to ask a resource, we can again use our CLI tool, create resource slice. We can call this resource slice GPU because it's a name to call it. We need to specify which cluster we want to ask the resources to, and then we can directly apply these resources to the Kubernetes API server, or asking Liqo to not apply the resource to the API server, but to create it as a YAML file in our file system and then edit it. So we can, for instance, try doing that and editing these resources. As you can see, is a custom resource definition that we created. We asked to Liqo to create for us, ask for us say 6 CPUs, and we can see that it created 6 CPUs as a request. For the demo, we are also requiring nvidia.com GPU, and we are requiring one of them, for instance. We can save this file and apply it. So when the file is applied, we can see that very soon we have a new pod that is VK GPU. So is a virtual kubelet running the GPU node that we required. We have a new node in our cluster that is called exactly the same name we named our resource slice resource. So we can see the resource slice. We can see the virtual node resource that, as we told before, is responsible of managing the life cycle of the virtual kubelet deployment and of the node.
So the amount of resources in the slices then are controlled at the node level, right? So you cannot ask for more than the static allocatable resources you define in the node, or there are other checks.
Okay, I can show you the YAML of the resource slice. So we have in the slice, obviously in the spec, what we created, we asked before. But in the status, the remote cluster has filled these resources we asked, what in the way we asked them, and then he defaulted the other resources to the number that is set by default in Liqo.
Okay.
We have a mechanism of resource slice class in order to have different controllers that can fill these resources. So the default one is basically a setting all you want, all the consumer cluster is requesting and defaulting the resources. But users are able to define new classes, and you can do on ingresses, or you can do in storage, or a very standard way to extend behavior in Kubernetes. So if the class is different from default, our controllers does not fill the resource status. So you are able to create your own behavior. Everything else is enforced to follow what is written in the status of the resource size. So the virtual node will have the same capacity that is in the status of the resource size. But this is a client enforcement. So we also have a server enforcement. So the quota that was in the previous slice. So we have a quota that has also exactly the same resources. We have a webhook that is you can enable it. This demo is not enabled, but you can enable it modifying this field in order to enforce that the limits, request limits are set on the pod that are scheduling in the remote cluster. And we have a webhook to refuse the creation if you go more than what the cluster provides you. I don't know if I answered to your question.
Yeah, perfectly. So you have both. You have
Yes,
the check on one side and also on the client side. Yeah,
exactly. And okay, we have the node, we have everything. So what we can do now is to enable Liqo for these namespaces. So what I was saying before, that Liqo works on namespace basis. So now we have no pod that is able to be scheduled to the virtual node. So what we can do is using again our LicoCTL tool to offload the namespace Istio system, because we use Kubeflow, and Kubeflow requires Istio. So we also need to make the services in the Istio system available to the remote namespace. We are setting the pod offloading strategy to local because we don't want the Istio control plane pods to be executed in the remote cluster. So we only want to make a networking connection to the Istio namespace. So we can run this, and then we can also offload the namespace dev. That is the namespace where we will create the, the Jupyter notebook pod. Here we are specifying both local and remote pod, because we want that pod can be scheduled where they want. And we can apply these. Obviously, it's again a YAML, so we can apply this with TTL or payload directly. Now we can see that the two new namespaces are created. The dev namespace and the Istio system namespace are newly created on this cluster. So we can go very quick to Kubeflow, start a demo Jupyter Lab pod with 3 CPUs, and for instance, 4 GB of RAMs. We are touching 1 GPU, and then we can launch it. So now the pod is scheduling. We can see there. Sorry, yeah, pods. Sorry, yeah, pods. We have the new pod. We can see that this new pod is running on node GPU, so it's actually running in the remote cluster. We can see that is actually running there. An interesting things we can see there is that in the pod we set the runtime class name Liqo, so we enforced this pod
If you
to
can
run.
scroll up, because I think your name tag is covering the last
Okay, sorry.
couple of lines there.
Okay,
Okay.
now I think you can see that.
Yeah.
So we set the runtime class for the pod to Liqo, in order to be sure that the pod is always scheduled to the virtual node. We can very fast see that if
So, which
Jupyter
kind
Lab has.
of configuration do you need from the Kubeflow perspective? I think pretty much
No
no.
one.
Yeah.
We only added two Kyverno policies in order to not forget to set things in in the interface when we create it. Basically, we added a Kyverno policy in order to set the runtime class, because it is not possible from the Kubeflow interface to set this runtime class. And then we set also the
Uh,
the storage class
so,
for the PVC, but
which is the policy
that's all.
then? So, where you base the policy on with respect to the interface?
Yes, they are Kyverno policies. I don't remember if they are cluster
So,
policies.
which flag do you need to pass from the interface to allow?
Okay, no. From the interface, you cannot set the container runtime. There is not
Okay, but yeah.
available in the runtime. You can do if you are using Kubeflow CRDs. So in the Kubeflow CRDs there is the flag, but not
No.
in the
That's fine.
interface.
I mean, but the policy itself, it will be based on something like, right?
Yes, if I remember, it's based on the namespace, the label of the namespace, so namespace
Okay.
offloaded, and the labels that Qflow is using on its pods.
Okay.
If I remember correctly what we did. But it's absolutely something very standard in Caverno policies. Okay, we can see that Jupyter Lab is working, and we are when it will. Okay, too many times. If we can check for the GPU, we can see that it is available on this cluster. We can see the GPU provided by the ArubaCloud node.
I love that. It's my favorite command for demo when it works.
No, notebooks and we have is ready, but I think we are not a engineer. So
Yeah.
I think that we can understand that everything is working.
Yeah. I agree. Totally.
And okay. Okay, here we have a very fast slide where we are specifying what Virtual Kubelet is doing in this scenario. So Virtual Kubelet is managing the life cycle of the virtual node. When Kubernetes schedule pods on time, the pods are reflected to the remote cluster. The reflection is basically a synchronization of resources. We synchronize pod volumes, services, etc. Between the offloaded namespace and its twin namespace in the remote cluster. We can also patch pods when they are offloaded to the remote cluster. For instance, we can add a node selector in order to specify a specific pool of nodes that the pod needs to run to in the remote cluster, etc. I think that for our demo, more or less, is everything. I don't know if you have question, we can go further. I think we are quite long, so so okay. Francesco, what's next in our roadmap?
Yeah, I think we have some time, so I can take the occasion
Okay.
to do one question that I
Okay.
already anticipated, so you are prepared. And what about, so you have this network fabric, and each pod can communicate with each other, but also in science, very often we need to move data from one side to the other, right?
Mhm.
So how persistent volume in general, and how, or for if there are other options that you are evaluating to share data between the two clusters
Yes.
in this case.
Yes, we have also a storage fabric. If you can see here, we have the PVC that Qflow created in our namespace is a Liqo storage class PVC. It means that Liqo storage class is not a real storage class; is a virtual storage class. So when a PVC is created with Liqo, we also create. It means that it's possible to offload the pod that mounts this PVC. But what Liqo does is to create this PVC in the cluster that runs the pod, and it creates it, for instance, with local path storage class in this case, but is creating it with a real storage class of the cluster that is running it. It means that this volume is binded to a specific cluster, so you can only run pods on that cluster. So if you are mounting this volume, we have a CLI command that basically backups and restore the PVC in another cluster. So you can move them, but obviously it's something that you need to manually specify, because we think that is not something desirable for a user to move the PVCs without any control. What we suggest if you want to connect storage from another cluster is basically to create an API, your API to access the data. So we can forward services. So you can have the API providing volumes, providing storage in a cluster and forward this service to the other cluster, or basically using some object storage like S3 in order to to use this storage over the network and not need to move physically the data between clusters, because we know that if we have 5 gig, okay, you can move them, but if there are some terabyte of volume, it's something that okay, is not very feasible to do. I think that's all. I don't know if
Yeah, I think it makes sense, and it's really dangerous to allow uh, for duplicating stuff here and there without
exactly.
opting in at least. So yeah. Um, yeah. Let's see. Oops. I was
Thanks.
muting Francisco because I was hearing your keyboard, but then I forgot
Yeah, sorry.
to unmute you. So yeah, you you wanted to say something or just to be unmuted?
No, just a few words about the future of Liqo, if you
Yeah,
still have
sure.
time. Yeah, Alessandro, can you? Okay, thank you. No, we released the RC1 and the RC2, which are release candidates for the V1 version, and we are planning to release the RC3 in the early 2025, at the beginning of the next year. So we think that this will be the last release candidate version before the V1 version. That will be the first stable version of Liqo with a stable API. And then we are also developing an enterprise product that will be probably a managed version of Liqo, but we are still at the beginning of this new journey. So stay tuned for information. And then we have some links about our documentation. If you are a friend of QR codes, this is the QR code for our landing page, or if you
Yeah,
prefer,
if you're
yeah.
not, you will find all the link in the description, so you can pass the link and I can put
Yeah,
in the
but the link
description.
is
Yeah.
liqo.io. Yeah,
No, no,
I
for
think that in
in
all
this
the
the
square
description.
is longer than Liqo.io.
Yeah,
all the
Looking,
previous one,
yeah,
all the previous ones also.
it's
Yeah.
our landing page. You can find all the links about our project and the GitHub, the documentation, and the Slack, which is the platform we use to interact with the community, where people ask for features and help. And yeah, basically that's all. And
Okay. Yeah. Very cool. I must admit that the network stuff is the one that caught my attention more. But yeah, it's just personal perspective. That's
yeah,
I enjoyed it a lot. So yeah, thank you guys. I think we have time if someone want to type something in the chat. I have one last question. So just 10 seconds to take the occasion. Okay, I suppose. I suppose not. Anyhow, so I think we are concluding. Let me remove all the overlays here and there. Also the chat. All right. And yeah. Okay, so sorry, I had to remove also this.
okay.
Yeah, I have nothing more to say. I just looking forward to give Liqo a try, and also invite anyone looking at this video to do the same. Thank you for your presentation, for your time, and for the nice demo.
thank you for the space.
Thank you too. Yeah.
No. that was fun. And yeah, thank you. And let's stay in touch. Pass me all the link that you want to make appearing in the description.
course.
Yeah, have a nice day and a nice weekend.
Yeah.
Sure.
Thank you.